Friction plays an important role in our everyday life. In this session, we will talk about dry friction. Friction forces develop when two surfaces in contact tend to move with respect to each other. Friction forces resisting the motion can either be good or bad. Without friction, we won't be able to walk or run. We will probably slide and fall as if we are on an ice skating rink. Similarly, we cannot use our brakes in our cars without friction, so friction is good. On the other hand, friction wears things out and leads to loss of energy. For example, high friction between the cylinder and the piston in an engine is bad. First, let me demonstrate when and how friction forces develop with a simple experiment. Please try this out yourself with some object such as a piece of furniture at home. I want to push this object. This is a cast iron weight plate. It weighs 7.5 pounds or about 3.5 kilograms. Right now this object is stationary and I'm going to place this on a table. The weight of this object is acting on the table and the table is applying an equal and opposite force resisting the weight. That's why this object is in equilibrium. I want to push this plate, so I'm applying a force now. Trust me, I am applying a force here. I suggest you try this at home with a heavy object so you can exactly feel what I am talking about. As you can see, the object is not moving even though I'm applying a force. This means there is some other invisible force pushing it back to keep this plate in equilibrium. This force can only occur between the contacting surfaces, and this is the friction force. So friction force develops when there is an attempt to move one surface against another. The free body diagram of this scenario looks like this. If I increase my pushing force, the friction force will also increase to maintain equilibrium. However, if I apply a very large force, there won't be enough friction and the object will start sliding. When the force I'm applying is just about equal to maximum friction force, and when the body is just about to move, this moment is known as impending motion. So friction is a resisting force that develops when one object attempts to move against the other. The magnitude of the friction force is equal to the normal force, which is the weight of the body in this case, multiplied by a factor known as the coefficient of friction. Friction force reaches a maximum value just before the body starts sliding, and the coefficient corresponding to this maximum friction is known as the coefficient of static friction, denoted by mu sub s. When the object is in motion, friction is still acting. The friction force in this case is equal to normal force multiplied by what is known as coefficient of kinetic friction. The coefficient of kinetic friction is less than the coefficient of static friction, and it is denoted by mu sub k. The value of coefficients of friction for various contacting materials is well established experimentally and available in textbooks and engineering handbooks. The graph here shows the relationship between the applied force and the friction. Finally, keep in mind that the coefficient of friction depends upon the contacting materials and the surface conditions. For example, the coefficient of static friction between your car tires and a dry road is about 0.7. Under wet condition, this can be much lower, like 0.3. We will solve various problems dealing with friction in the next few videos.